Collecting quality soil samples is very important to develop nutrient management plans. Furthermore, some farmers use soil samples to help develop management zones for variable rate seeding. This module will cover 3 objectives: the importance of soil sampling, including soil sampling schemes such as zone versus grid soil sampling, how to use Google tools to create grid soil sampling points, and how to begin soil sampling your fields.
Hi, I'm Emma Matcham. I'm a PhD student at UW-Madison, and I previously got my master's degree at Ohio State in Dr. Laura Lindsay's lab. Most of my research is about the intersection of agronomy, fertility, and big data. Today I'm sharing some information about soil sampling, starting with the basics about why we soil sample, and then I'll get into a comparison of different soil sampling methods. Finally, I'll share some details about how to get started with your own grid soil sampling. Thanks for being here today. We soil sample because soil test values are the basis for our tri-state fertilizer recommendations for corn, soybean, wheat, and alfalfa. Soil testing provides an estimate of crop available nutrients in the soil at a given location and given time. One question I get frequently is, are we diagnosing current nutrient deficiencies or preventing future deficiencies? And we can do either. If in 2020 you observed symptoms of nutrient deficiency, but aren't sure what it was, soil testing may help you diagnose the problem. Or if you see a spot in a yield map that has lower yield, but you aren't sure why, you may want to check that it wasn't caused by a nutrient deficiency. But today we're going to focus on soil testing strategies that can help prevent future nutrient deficiencies. You can also sample for soil health or pests like nematodes, and there are resources available at these links to help you learn more about these types of soil testing approaches. I like to think about testing for soil fertility as finding a spot on a number line or benchmark. We know our soils have some amount of phosphorus in them, and we know from the tri-state fertilizer recommendations that we do not expect to see a yield response to fertilizer when our soils are above the critical level. We also know that there's no agronomic reason to apply fertilizer when our soils have a higher nutrient concentration than the maintenance limit. We're testing to see where our soils fall relative to these two values. Critical levels vary by state, nutrient, and crop. If you're growing soybeans in Ohio, the critical level for phosphorus is 20 parts per million. The maintenance level is 40 parts per million. Your soil test values might fall here, within the maintenance range. At this level, we recommend applying enough nutrients to replace the nutrients removed during harvest, otherwise called replacing the nutrients lost via crop removal. Where your soil test value falls relative to the critical level and maintenance level is important to know for making management decisions. If you'd like to learn more about how to modify your management based on your soil test results, I highly recommend reading the Tri-State Fertilizer recommendations. They were just updated this year in 2020, and the new publication has a lot of valuable information. It's important to know if your soil test values are below the critical level because low soil test values are associated with lower yield. In a 2017 study in Ohio, soil test phosphorus values below the critical level were associated with soybean yield 7 bushels per acre lower on average as compared to fields with soil test phosphorus levels above the critical level. And low soil test phosphorus levels are not rare in Ohio. In a 2017 survey of Ohio fields, 1 out of 5 soil samples had soil test phosphorus below the critical level. In this figure, fields with at least one soil sampling location below the critical level are shown as closed circles, and fields with all soil sampling locations above the critical level are shown as open circles. This trend is similar for soil test potassium, where 1 out of 4 sampling locations had soil test potassium below the critical level, and low soil test potassium levels were associated with a 4 bushel per acre yield reduction. We've talked about why we want to know soil test values, but now we need to actually go determine what our soil test values are. There are 4 basic steps to this process: planning, pulling your cores, sending samples to the lab, and interpreting your lab results. This video is going to focus on the first 2 steps: planning sampling and pulling cores. There are 3 main approaches to soil sampling: whole field, zone, and grid. Whole field samples, shown here on the left, are taken by walking in a zigzag pattern through your field, taking a core or two every few hundred feet as you walk. Then you'll mix all your cores together into a composite sample that represents the average fertility across the whole field. Another option is zone sampling, where the field is split up into different management zones. These zones can be delineated by soil type, past yield maps, historic land use, or other features. In this method, you'll walk to a zone, take 10 or more cores, mix them together, and then do the same for subsequent zones. In zone sampling, each sample represents the average fertility of the zone it was taken in. You could also grid sample fields. In a grid sampling approach, you plan sampling locations in a grid pattern across the field at the spacing you desire. 2.5 acre grids are common, but some folks use a 1 acre grid or even a half acre grid. At each sampling location, you pull 10 or more cores and mix them together into a composite sample. The test result from each composite sample represents the average fertility of that particular grid cell. As with all things in life, there are trade-offs between methods. To help you decide which approach is best for you, I'm going to compare methods based on 4 parameters: cost, prior information about your field needed, effort in the field, and information received from the soil test results. Whole field samples are low cost since you're only paying to get one sample run at the lab, and you don't need prior information about your field to get started. Once you get to the field, it's pretty easy to pull the samples, but since you aren't putting much into whole field samples, you also don't get much out. There's just an average fertility value for the whole field, which might mask problems. Do you have a low yielding spot in a field? Maybe it's low potassium causing the low yield levels, but if you only ever pull whole field samples, you'll never know. Out of the 3 methods, grid sampling will have the highest upfront cost. Zone sampling has a variable cost based on how large your zones are, but the per acre cost for zone sampling tends to fall between whole field and grid sampling. Zone sampling requires the most prior information about your field in order to delineate the zones and plan your sampling effectively. Grid sampling requires you to know much less information about your field, but you do need to know the field size so that you can lay out your grid prior to sampling. Once you get into the field, grid sampling requires the highest amount of effort. You just pull a lot more soil cores if you're grid sampling as compared to any other method. Finally, grid soil sampling does provide a lot of information about your field as compared to zone or whole field sampling. If you're sampling a 25 acre field using a 1 acre grid size, that's 25 individual soil tests. You might see some surprising low fertility spots or high fertility spots in your field when you run this many tests. And maybe you want to use some variable rate fertilizer applications to address that. But if your zones are delineated well and your zones are pretty homogeneous, you're still getting a fair amount of information out of your soil sampling program. If you don't use your soil maps for variable rate seeding or other precision ag applications, you might not actually utilize the additional information from grid soil sampling, or you might not have the funds to pay the upfront costs of grid soil sampling. Regardless of the soil sampling approach, whole field, zone, or grid, there are some things to keep in mind. Every composite soil sample should be made up of at least 10 soil cores, and a composite sample should represent no more than 25 acres. If your field is larger than 25 acres in total, we'd recommend you move away from a single whole field sample and into a zone or grid system. Particularly for those fields that are larger than 25 acres, deciding between zone and grid is hard. Some things I like to keep in mind when I compare these approaches is a study by Mallarino and Witry in 2004, which compared zone and grid approaches based on their ability to accurately measure within field variation in organic matter, pH, phosphorus, and potassium. Let's walk through this study performed in Iowa in a little more detail. They had 1 grid sampling approach and 3 different zone approaches. All approaches were compared based on how homogeneous the zones actually are, since when we soil sample, we assume fertility level is the same across each grid cell or zone. Overall, grid sampling and integrated zones reflected spatial variability effectively. The individual grid cells and integrated zones were more homogeneous than the zones made on soil series or elevation alone. This within zone homogeneity is important because you're only getting one soil test value from each zone, And you want that value to be an accurate estimate for the whole zone when you're trying to avoid future nutrient deficiencies. I did see some differences in the performance of the integrated zone and grid sampling. Grid samples were better for sampling for phosphorus, and zone samples were better for other properties tested in the study. So zones make a lot of sense, right? They performed really well for 3 out of the 4 properties tested, and zones cost less money than grid sampling. This is true, but there are still some cases where grid sampling might make more sense. First off, if you're really concerned about phosphorus values, but less concerned about pH or potassium, grid samples might be a good choice. The other time grid sampling makes a lot of sense to me is when you don't have much prior information for the field to make your zones. Maybe it's the first year you're renting this field, or you've only previously used whole field sampling and don't feel confident making zones. Grid sampling makes a ton of sense in that case. Integrated zones are also an art form, and they can vary based on how much importance you give each of the layers used to make the integrated zones. Planning for grid sampling is much less subjective. I use grid sampling for a lot of my own research, and this year I took a few videos about the process.
One of the questions I get most often from folks interested in starting grid soil sampling is how do you know when you walk into a field that you're taking a sample from the right location? And how do you make sure that all of your soil samples can be mapped at the end of the process? Today I'm going to share a few tips for how to use Google Tools to create the maps you need to go out and go soil sampling. The first step is to go to google.com/maps. And from there, you're going to click on the menu in the left side. Go down to Your Places, and then select Maps. Now you're going to go to the bottom and hit Create Map. This first procedure I'm going to share with you today is meant for folks that have a grid soil sampling map from their farm from a past year, and they'd like to go back and resample the same locations. So you already know where you want to sample, but you need to find a way to get that to your phone so that you can actually go out and pull the samples yourself. To do that, the first thing I like to do is label my map so that I can go back and find it later. This is going to be soil sampling example 2 2020. And then I need to import the layer where my file of locations for soil samples is already stored. So I have a CSV file that is stored on my desktop called example soil sampling location, and I'm just going to upload that using the import button. Now Google Maps needs to know which of the columns in my file is for the latitude and which of the columns is for the longitude. So I'm going to click X and say that that's my longitude, click Y and say that's my latitude. Then I can click continue. And now in order for each of the spots on the map to have a label, we have to say which of the columns in our data sheet are the labels. And for me, that's sample num. Once it's loaded, Google Maps will automatically zoom in to the correct scale so you can view your whole map. And I like to make sure that before I go to the field, each of the markers in the map has the soil sample number right next to the marker. This makes it really easy for me to label my bags. And to do it, I click on Uniform Style on the left-hand side, and then go to Set Labels, Sample Number. Now you can see all my labels are right there, and it makes it very easy for me to open the map on my phone and walk to the location, label my bag, pull my sample. Now, say you don't have soil sampling locations already identified, and you need to place pins in a map to create your soil sampling plan. You can go back to Your Places, Maps, Create Map, and label your map once again. Soil sampling example 3, 2020. And you can search for your farm. I'm going to use Arlington Ag Research Station. This is a university farm for UW-Madison where I happen to work. And I'm going to create an example with one of their fields. In order to see the field boundaries, it helps to use a satellite image instead of the blank base map. You can do that by going to the window on the left-hand side and clicking Base Map, Satellite. Now we're going to use this small field here at Hopkins Road and Badger Lane. And the first thing I'd like to do is know how big that field is. So I'm going to click the measure tool and then click around the border of the field. Right now it's measuring in length, but as soon as I connect my line to my starting point, it'll actually give me an estimate of the area of my field. So this is a 6-acre field, and if I want to use 1 acre grid cell size to sample this field, I'll need 6 samples within the field. I can place my samples using the Add Marker button here, and then I'll click exactly where I want the marker to go. So this is going to be sample 1, add marker, sample 2, sample 3, sample 4, just 2 more here, sample 5, and sample 6. So you'll notice that my points aren't perfectly laid out. That's partially just because I worked quickly for those of you watching the video, but you can go ahead and click once and then click and drag each point and lay them out a little bit more evenly. And if you took your time with this process, you could get quite close to an even grid, especially if you laid them out and then measured the distance between each of your markers to make sure it's fairly even. So you could use that measure tool we used at the beginning. And this is another way to start grid soil sampling. It creates essentially the same map as the last procedure I showed, but it's great for folks who don't already know where they want to sample. If you want to label them, you can go back into the individual styles, set labels, use the name, and then all the sample numbers come up. And it's just a very easy to use map. The last option I'm going to explain for you folks is if you don't have a cell phone or another GPS that you'd like to take to the field with you, but you still want a grid soil sample, an easy way to do it is to measure how far your first sampling location is from a known point in the field. And I like to use the field corner, and I'm going to measure parallel to Badger Lane and see how far over that first sample is. It's about 86 feet. And then I'm going to reset my measuring tape and measure down and see how far it is there. So it's about 155 feet in that direction. And if I were going to walk out into this field without a GPS, I could walk to the field corner and use my measuring tape to find 86 feet parallel to Badger Lane, and then 155 feet parallel to Hopkins Road, set a flag at each point, and then walk in and find my sampling location. From there, from sample location 1, I could walk whatever distance it is between sampling location 1 and 2. Again, parallel to Hopkins Road, so I might need to move that pin for sample 2 for this to work out. But if I'm walking in a known direction for a known length, so in this case 234 feet, I would be able to take my sample and label it, and then come back and know that I pulled soil from the right location because all of the ground measurements lined up. So those are 3 different ways to use Google Maps to create maps that you can use for grid soil sampling on your own operation. Whether you already have sampling location, latitudes, and longitudes in a spreadsheet from another past year, or if you're new to grid soil sampling, want to use your cell phone for taking your samples, or if you don't want to use your cell phone and you would just like to measure the ground while you're in the field. I hope this was helpful.
I showed this general step slide earlier in this presentation and just wanted to reorient you to where we are in the soil sampling process. At this point, I've shared some information for choosing between whole field, zone, or grid sampling. You might already have zones planned for your fields, or you might be interested in trying one of those 3 grid soil sampling methods I just shared. Now we're just about ready to pull some soil cores, so I'm going to share 2 videos from a day soil sampling this past fall. If you're planning to use your phone as a GPS when grid soil sampling, you need to make sure your saved map is accessible on your phone. Any maps made in Google Maps are available on both desktop and mobile as long as you're logged in under the same account. To double check your map, open Google Maps on your phone. You'll notice a small menu at the bottom of the screen. Click Saved on this menu. In your saved places, you can see any locations you've pinned or starred in Google Maps. Click Maps at the bottom near the right, and it will take you to a list of your maps. Click on the map you want to use and make sure that the pins are in the right spot. I have a short video to share next about what equipment I bring with me when I'm soil sampling.
I am at Arlington Ag Research Station getting ready to go soil sampling today, and I wanted to show you what I bring with me. First off, I have quite a few soil probes in my car, so that if one bends or breaks, I have more. I also have a few buckets to put soil cores in before I dump them into bags, and more buckets to carry my bags of soil samples around with me. I have some blue bins in case my buckets get full and they stack nicely in my car with the soil samples in them so they don't dump over. And then I have another bucket which has my labeled sample bags already in there and some work gloves. I have Sharpies in case I need to relabel any bags. It is Wisconsin after daylight savings time ended, so I have a headlamp in case it gets dark. Got a screwdriver and a pocket knife so that if soil gets stuck in my soil probe, I can get it back out. And a spare cell phone battery with a charging cable since I'm using my phone as a GPS. Lastly, I wanted to mention that I bring a ruler or a measuring tape to the field with me whenever I pull soil samples. And that's so that I can mark a consistent depth. Today I'm going to be taking 8-inch samples, so I've already marked my probe using that Sharpie to a depth of 8 inches. That means that if I insert the probe into the ground to this line, I know I'm getting an 8-inch core. I don't need to mark my red probes because those are 8 inches up to this point, so it's pretty easy to figure out if my samples are the right depth.
Once I get to the field, I open up my map again. The pins are the locations I plan to pull a soil sample. They are not in a true evenly spaced grid on this map because I am sampling at the center of plots for a spring fertilizer trial instead of grid sampling a field. I can zoom in better to see where I am relative to each pin. My location is the blue circle, and the blue shadow around my circle is how Google shows us GPS error. The circle represents a maximum distance your true location could vary from the location of the circle on the map. The darker blue funnel shape next to your circle is the direction your cell phone is facing. Note that this might not be the direction you are walking in. It is the direction your cell phone itself is facing. As I get closer to a point, I zoom in further so that I can get as close as reasonably possible to the base of the pin, which represents the spot I want to pull soil samples from. I have one final video I'd like to share today that goes over how I pull soil cores at each sampling location.
Alright, so I just navigated to sample point K36 in my field for today. And I'm going to take 10 cores from a mixture of within a row and between rows within 1 yard, 1 meter of the sampling location I'm in. And then I'm just going to put the cores in my bucket. This field was harvested in the last week or so there's quite a lot of crop residue. And I'm just going to pick it out of my way so that I can get better soil samples. This field has not had manure in recent years, but if it were a field that had manure, I would want to avoid any manure piles while sampling. Other things to avoid while you're sampling are places that look really, really dry or really, really wet. You also want to avoid anything that looks like it has a lot of visible insects right on top of it. And I'm taking 10 to 12 cores per sampling location today. If this were a field with a recent banded fertilizer history, I might want to take 15 to 20 cores instead of just 10 to 12. I mentioned earlier that I need my cores to be a consistent 8 inches in depth. That's because nutrients stratify, and if all of my samples are the same depth, my sample is going to be more representative. If I had some samples that were much shallower, then my sample would overrepresent how many nutrients are in the sample. And to be honest, I totally lost count of how many samples I've taken since talking to you. I'm just gonna go ahead and take 2 more and then pour my sample in my bucket. I'm at sample location K36, so I'm going to find a bag for K36. I conveniently labeled them before I came out this morning. Break up my cores a little bit so they fit. And there we go. I'm going to seal up my bag and put it in my other bucket so that I can carry it to my next sampling location. And I'll just do the same thing for all the sampling locations in the field today.
I'd like to remind you of a few things I touched on in the field, just because they're important for making sure your soil samples are in fact representative of the grid cell or zone you're sampling in. Pull at least 10 soil cores for every soil sample, and pull those cores from a consistent depth. We typically recommend 8-inch soil sampling depth. Keep in mind any history of banded nutrient application, because fields that have had banded nutrients in the past might require you to pull more than 10 cores per composite soil sample in order to accurately estimate the fertility in a given location. While you're pulling cores, avoid spots that are particularly wet or particularly dry, or any spot that's a different color. You'd also want to make sure that your soil sample is in fact just a soil sample, so you should avoid spots that are anthills, piles of worms, large piles of detritus, because you want the sample to actually be soil. Once you're done pulling soil samples, the hard part is over. You can seal up your bags and mail them to your lab of choice. When you get your lab results back, you can find information for how to interpret the results in the Tri-State Fertilizer Recommendations for corn, soybean, wheat, and alfalfa. This publication has great information on critical levels, fertilizer application rates, fertilizer application methods, and more. In summary, soil sampling gives us the information we need to apply fertilizer at the right rate and prevent future nutrient deficiencies. There are trade-offs between whole field, zone, and grid sampling approaches, and while you're deciding which approach makes sense for you, keep in mind your field size, soil sampling cost, and whether you have enough information to delineate homogeneous zones. Soil cores should always be taken at a consistent depth, regardless of the method you're using for soil sampling. Thank you so much for watching this video today. I really enjoyed sharing some of my soil sampling process, and I look forward to talking to you more about soil fertility in the future.